Okay, let's dive right into this. Welcome everyone to today's explainer. If you're joining me right now, you're probably someone who builds, tinkers with, or, relies heavily on retrieval augmented generation or RAG systems. And today, we're tackling an absolutely foundational challenge in building highly reliable generative AI. It's the challenge of making sure your system actually finds the right information in the first place. We're going to explore a real game changer of a concept called score fusion, which is all about fully optimizing hybrid retrieval.
But first, I've got to ask you something that has probably kept you up at night if you work in this space. Why is your AI missing the most obvious answers? Have you ever built an app, fed it thousands of documents, and found that while it perfectly understands the general gist of some complex philosophical question, it completely fails to pull up a document when you search for an exact serial number or a rare acronym? It's incredibly frustrating, right? Well, today, we are going to fix exactly that.
So, here's our agenda for the explainer. First up, the retrieval dilemma. Second, an introduction to score fusion. Third, 4 core fusion techniques. Fourth, trade-offs and challenges. And finally, we'll wrap up with winning production strategies.
Let's start right off with Section 1, the retrieval dilemma, and explore the flaws of relying on just a single search method.
Think of your search systems like a pair of detectives working a really tough case. Vector search? Well, that's your brilliant behavioral profiler. It understands semantic meaning, the nuance, the underlying motive behind a user's query. It's absolutely amazing at handling paraphrasing. But, and it's a big but, it is notoriously weak at finding rare terms or exact keyword matches. Then, on the other side, you have BM25, your traditional sparse retrieval. BM25 is your meticulous forensic investigator. It honestly doesn't care at all about the meaning of the crime. It is strictly looking for exact fingerprints. It matches exact keywords perfectly, but it's terrible if the user paraphrases their question. So, you see the dilemma. If you use only vector, you miss the exact keywords. If you use only BM25, you completely miss the semantic context. Which brings us perfectly to Section 2, introducing score fusion, where we figure out how to combine the best of both.
If these two solo artists are flawed on their own, how do we get them to collaborate? The answer is score fusion. By definition, it's the process of combining multiple retrieval scores, most commonly BM25 and vector similarity, to achieve higher recall and better ranking. Going back to our detective analogy for a second, score fusion is like the intelligent chief of police sitting at the desk, taking the behavioral profiler's report, looking at the forensic investigator's report, and intelligently combining them both to pinpoint the exact suspect.
So the crucial point is this mental model right here. If you remember literally nothing else from this explainer, please remember this. Vector equals meaning. BM25 equals exact match. And fusion? Fusion equals the best of both worlds. By running a query through both a vector database and a BM25 system, and then merging those results, you ensure that you capture both the broad context and the highly specific, rare keywords your users are looking for.
But how do we actually do this merging in practice? Let's move to Section 3, core fusion techniques. Because at the end of the day, it's math, not magic.
There are 4 primary ways developers execute this merger. First up is the weighted sum. This is the most widely used approach because it lets you actively tune how much you care about semantics versus keywords. Second, we have reciprocal rank fusion, or RRF. Now, instead of looking at the raw numerical scores, RRF just looks at the ranks. Like, where did a document place in the vector search versus the BM25 search? It combines those ranks, which makes it highly robust when your scores aren't easily comparable. Third is max score. This one is super simple. You just look at the vector score and the BM25 score and just take whichever is higher. It's incredibly easy, but a bit less stable. And fourth is learned fusion. This is the advanced tier. It actually uses machine learning, specifically learning to rank models to intelligently figure out the absolute best combination.
Let's zoom in on the first one, the weighted sum, because it really is the industry standard. Now, what's really interesting about this slide is the formula, specifically that alpha symbol right in the middle. Alpha is your weight parameter, sitting perfectly on a scale between 0 and 1. Think of it like a slider. If you set alpha to 0.7, you're telling the system to lean heavily towards semantic, vector-based meaning. But if you slide alpha down to 0.3, you're giving the majority of the voting power to BM25, prioritizing exact keyword matches. Tweaking this single little variable fundamentally alters how your AI retrieves knowledge.
Of course, nothing in software engineering comes for free, right? That takes us into Section 4, trade-offs and challenges, dealing with the friction of reality.
Let's look at what happens when we push this stuff into a live application.
Whenever you optimize for one metric, it inevitably costs you another. It's like pulling a lever. If you increase your vector weight, your semantic recall goes up. You'll catch way more related concepts, but your keyword precision goes down. Conversely, if you pump up that BM25 weight, your exact matching improves, but your system loses its semantic understanding of the user's actual intent. And finally, as you increase the overall complexity of your fusion, like say moving to a fancy learned fusion model, your accuracy will absolutely soar, but so will your latency. Your system is just going to take longer to answer.
Because of these trade-offs, you have some absolutely crucial design considerations to keep in mind. The most massive one here is normalization. Vector scores and BM25 scores naturally operate on completely different mathematical scales. You simply cannot just add them together out of the box. You have to normalize them first so they speak the same language. You also need to tune your weights specifically to your domain. A legal document database is going to need vastly different weights than a customer support chatbot for sure. You have to monitor latency because remember, you're now running two separate retrieval systems at the same time, and you absolutely must handle deduplication because both searches are very likely going to find some of the exact same overlapping documents.
So as a quick piece of advice, try to avoid the common developer mistakes we see all the time in the wild. Number 1, skipping that normalization step we just talked about. Number 2, using fixed weights for all queries, totally regardless of the user's intent. Number 3, failing to re-rank the results after they've been fused. And number 4, just ignoring the latency penalty entirely until users start complaining that the app feels sluggish. So how do the pros avoid all this? Let's move into our final section, production strategies, and see exactly how the experts set this up. Let's move to and see how this builds into an absolute gold standard production pipeline. It's a journey, and it happens in stages. Step 1. The user's query comes in and goes through both dense, that's your vector, and sparse, that's BM25, retrieval, simultaneously. Step 2. Those results hit our score fusion block, where they are intelligently merged. Step 3, and we don't stop there. We pass that top K list into a re-ranker, quite often a cross-encoder, to meticulously grade and reorder the results. And finally, step 4, that perfectly curated list is handed over to the context builder and the LLM to generate the final, beautifully accurate answer for the user. To really supercharge this flow, professionals use dynamic production tactics. The real secret sauce here is dynamic weighting. Instead of a fixed alpha, they analyze the query first. If a query is heavy on exact serial numbers or specific keywords, the system dynamically turns the BM25 weight up. If it's a broad conceptual query, it cranks the vector weight up. Add in some caching for your fused results and multi-stage ranking, and you have an incredibly responsive, highly accurate application that feels almost like magic to the end user. And this brilliantly illustrates the ultimate takeaway of our entire explainer today. Fusion improves recall. It makes sure you cast a wide enough, smart enough net to find all the right documents, whether by keyword or by meaning. Re-ranking improves precision. It takes that wide net and perfectly orders the catch, so the AI only sees the very best pieces. Together, they create the absolute best RAG performance possible. So, now that you understand the mechanics of the retrieval dilemma, the math behind score fusion, and the pipeline needed to build it out properly, the ball is entirely in your court. I'll leave you with this. When you sit down and open your codebase today, how will you tune your alpha weights to unlock your AI's true potential? Thanks so much for joining me on this explainer, and happy building.